Hi everyone, my name is Thomas, and a few years ago, actually, with a bunch of friends, we had the idea of making the internet a friendlier place. How so? By enabling peer-to-peer communication everywhere on the internet. Where everywhere before we had unilateral communication from site owners to the web servers, suddenly we wanted to have peer-to-peer communication everywhere on the internet. So for that, we developed the Hey product, which is actually a browser extension that sits on top of every website and offers you a chat room depending on the URL you sit in. So you can actually chat with all your friends and all peers that are on the same website as you are. So actually we had this idea quite some time ago, and then it's only recently, actually 1 year and a half ago, that we thought, okay, what about actually including the blockchain in this product so we make it even more transparent. So we use the blockchain to actually reward users when they provide meaningful content to the platform, and also to actually share the value that is created via the platform, because we sell contextualized ads in the chat, and actually the users get a share of these advertising revenues thanks to tokens. So we decided to embark on this journey of creating a social network on the blockchain. But how am I? You might know about the challenges linked to that. So we basically were faced with 4 key challenges. The first one was about throughput. So, how do you deal with the huge amount of transactions that you get when you have dozens of users all interacting at the same time with each other? We know today that Ethereum scales with up to 20, 30 transactions per second. That's definitely not enough for your use case. And then user experience. If you want to build a social network, it's not a one-player game. You need like thousands and thousands of users to make this a meaningful experience where you interact with plenty of people. But to get this mass adoption, you need a good UX. And UX is always, clashing with security, and blockchain is very secure. So how do you make sure you have a UX that is friendly enough so that many people come and join your network? And then what about volume? If we start storing all the content of the posts, etc., then we're gonna hit like storage costs very, very high. So how do we deal with that? And then actually, last but not least, this creepy challenge of compliance. The regulatory environment around blockchain is still fairly undefined, and there is still no clear framework in place to say actually who should be responsible if hate speech, for example, is ever recorded on the blockchain. Hate speech has got to be removed promptly on Facebook, for example, otherwise Facebook is held accountable. So we wanted to make sure that we would never be accountable for things that users actually would post on the blockchain, on the content. So we were faced with these challenges, and after quite some thought process, we came up with two solutions, thankfully, for that. So about the throughput and UX challenges, we decided to resort on a sidechain solutions. So I don't know if some of you here in the room know about these little fellows. Probably, like if there are Ethereum developers within the room, you've seen them. They are actually the crypto zombies. So we decided for our sidechain technology to use technology provided by Loom. They are great guys. So they were first known for crypto zombies, so a series of tutorials about how to learn Solidity, and they've developed this whole technology of their sidechains to support actually gaming and social kind of use cases. So which were like the perfect fit for what we're trying to do at Hey. And then next to that, talking about volume and compliance, this actually forced us to focus on the so-called minimum immutable product. When you're building something on the blockchain, you don't want to put all your feature set, like all your architecture and systems on the blockchain. You want to make sure you actually use blockchain only for what it's best at. So we really focused on identifying what it is that has to be made immutable, so that things are open enough, so that the user trust us enough, but at the same time, we make sound architectural choices. And that's how we actually ended up only storing like the ultimate output of a user's interaction resulting in value creation. So let me explain that. We've decided not to store any content from the users on chain. So we do not store posts, we do not store comments or whatever. We do not store username. All that we store is actually, interactions that occurred between these users. So for example, Alice is giving 1 like to Bob, and so actually Bob will receive one karma, 1 token, and this is stored on the blockchain. But nothing about the content. So the storage requirements are way lower, and actually we also work around the compliance issue linked to that. So to give a little more insights about Loom, so the sidechain technology that we are using, they're really great. So they have a team of nearly 100 people now worldwide, so doing plenty of exciting stuff. So their sidechain technology is basically relying on a Tendermint protocol, so using delegated proof of stake with so-called validators. So they are the miners of this kind of protocol. And then they basically run the Ethereum virtual machine, meaning like all the folks that have learned to code on Ethereum, you know, using Solidity or Viper and stuff like that, they can actually take the contracts and just deploy them on Loom. It goes like that. It's super easy. So you have all the stack with Web3.js, etc. So really great for us. There's a huge developers community. And basically they're focusing their technology for the use cases, as I was saying, of gaming and social networks. So for example, actually the very first use case for the Loom sidechain was a delegate call. So you can think of delegate call as a kind of a Stack Overflow, specifically for things related to Ethereum. And the cool thing with delegate call is that it's running fully on the blockchain, like even the content, etc. And it was a bit the laboratory of Loom. And one of the great things actually that they've done with this delegate call, and that we plan at some point to do on Hey, is actually, you know, writing smart contracts directly in Go, and then compiling them and having them embedded directly in the binary of the chain. Meaning like really all your things that would be normally interactions with smart contracts using, like smart contracts interfaces, suddenly they become embedded in the very fabric of the chain, making it way more efficient and secure actually. So that's, you know, an alternative for people that code well in Go and are not so much at ease using Solidity. They can actually use that cool language that Go is. And so we've decided to use them, and you know, we thought about our architecture. Don't worry, anyway, it's unreadable. We won't go through all the boxes on that diagram, but basically what I would like to highlight here is that in our architectural choices, we've really had this mentality of, you know, minimum immutable product. So you see, like, there's shitloads of business logic everywhere, like all these microservices, etc. But the interesting thing is that actually there are very few things put on chain. So here you have a few smart contracts on the main chain, so on Ethereum. You have mainly the token contract. And then on the side chain, so on Loom, you have, again, the token contract, and then the Karma contract. Karma is like on Stack Overflow, the reputation that you can ultimately exchange for tokens. But the interesting thing is that everything around is not on chain, but we make sure that this is the part, you know, that users, we know they care about, is that once they have earned a reputation in Karma, they are sure that it won't get, stolen. It's fully transparent. And actually, you see a lot of arrows, and namely arrows in between the side chain and the main chain. So why is that so? That's because, in Hey and also delegate call and or other use cases, what you have is that users will actually want to transfer assets, so tokens, for example, ERC20 or 721, from main chain to side chain, and then from one side chain to the other, etc. And you gotta have this interoperability of the chains between each other, so that they are really usable. And so that's why a lot of arrows. And actually, we're very lucky in the case of Hey, because we don't have to rely on very complex constructions to be able to have this interoperability of chains. Because probably you know about Plasma, Plasma Cash, or Plasma Prime, or all these very advanced research projects that have the purpose of moving assets from the main chain to the side chain and then back to the main chain. And it's all very complex because you gotta make sure that when a user actually trusts the sidechain owner to move an asset from the main chain to the sidechain, it won't disappear in the sidechain, making it unusable on the main chain. So there's really a risk for users when they transfer assets to a sidechain that they lose their assets. So that's why Plasma has been built, and it's actually fairly intricate intellectually. But we're very lucky actually because here we rely on a very stripped down version of Plasma, where actually we only need to care about users transferring assets from the side chain to the main chain. So that is, users will actually gain reputation, karma, tokens on the side chain, and we basically, offer these tokens, offer these assets to them, thanks to their activity and contributions. And then what they need to do is actually be able to redeem these assets on the main chain. And so they need to bring them back. But it's not like they need to go from the main chain to the side chain and then back to the main chain. So only assets created here and then transferred there. So let's take a little look at how this works. It's called the transfer gateway pattern, something that Loom has been pushing forward and open sourcing. So really doing a great work on this. So how does it work? Basically, let's say that this user, Alice, has earned karma and tokens on the side chain. And then she wants to actually redeem them so that she can trade them, on any exchange or with friends on the main chain when they have really monetary value. So what Alice will do is actually on the side chain she will burn her tokens, and actually have a proof that she locked or burned these tokens. Submit this proof to the validators, so the miners of the side chain, and the validators will verify the claim that the tokens are frozen, and emit a withdrawal message that is signed by them, by one of the validators, give it to Alice, and then Alice, with this signed message, will actually head to the main chain and provide this signed message from the validators to the transfer gateway. The transfer gateway will be able to, verify that it was signed indeed by one of the addresses of the validator. And if only this is true, then actually the transfer gateway will release the equivalent amount of tokens on the main chain account of Alice. And so what we have is basically an exchange of signed messages from one chain to the other, and that is kind of the magic that makes this transfer possible. So thanks a lot for your attention. I hope you joined the conversation on Hi.network. The product is in beta version on the Chrome Web Store for now, so hopefully see you there. Thank you.
We have time for a few questions.
Hello. So first of all, I'm very impressed by your approach to scalability. I think that this is how every decentralized application should be built.
Thanks.
Also props to using Loom. And my question is, so karma has a value, right? And have you thought about how do you ensure that a user cannot CBO attack the actual network and just like earn karma using a bot or something?
Mm-hmm. Yeah, so that's a very good question actually, because I did not mention explicitly that on the Loom sidechain you don't need gas actually to perform transactions. So you can do thousands of transactions per second. But of course, gas is there for a purpose, is to reward miners. That's one. Also to prevent Sybil attacks. So really people spamming the network. And how is this prevented? It's actually in the very fabric of what Loom is building. They have this built-in reputation system where you need to kind of warm up your address to begin being able to send a lot of transactions. So you have this built-in kind of reputation system that ultimately allows to block and ban people that are spamming the thing. And then next to that, actually, we have a kind of oracle in place that makes sure actually that people cannot reward each other with karma, etc. On the high smart contracts if they have not previously registered as users of the network. So it's not like anyone can begin spamming the network like mad. They have to be registered. But it's an ongoing field of research. I know like Loom is spending a lot of time actually having all this reputation system in place to avoid spamming.
Okay. Have you considered identity or maybe some proof of identity?
Yeah, there was this question there in the back about using identity providers on chain. Definitely it's on the roadmap. Yeah.
So I'm not very familiar with Loom, but you said that you use standard mint and delegated proof of stake.
Mm-hmm.
So this is kind of it's a permissionless network, if I understand correctly.
Yeah.
How do you how the contract on the main chain is going to verify the signature of a permissionless network? Because if you need to know the validators, and validators can be added all the time, then that contract cannot store them
Yeah, so the question is about how do we ultimately, like, the ability to transfer assets from the sidechain to the main chain comes down to the transfer gateway, so this recipient on the main chain being able to validate that the transfer transaction is well signed by a validator. So how do you actually deal with the governance of making sure that like these validators are legit and are reflected? And actually there it's actually like how to say, the way that it's working now is firstly Loom has been running 100 validators fully internally. Okay, only these ones were like validating, so no issue. And now what they are doing is actually, you know, onboarding every month actually new validators, and all these validators, all these nodes actually they belong to companies using using Loom and their technology as yeah. And so basically supporting the technology by becoming a validator. So it's not like anyone can enter the validator network. And these validators, because it's important to mention actually, are being rewarded with tokens, etc. And the monetary value ultimately comes from the developers of applications. So Hive, for example, renting this network. So it's like blockchain as a service, really. Good.
We'll have maybe time for the last question. Yeah.
Thanks for the talk. I have a question. You said, so basically users get reputation and then they want to exchange this reputation for tokens
Yeah.
or eventually sell it. But why people will buy those tokens?
Yeah, so that's in the economic model, if you wish. Ultimately, Hey is a company, right? We gotta make a living. So the idea is to monetize the attention of the users, but in a very explicit way. So putting actually ads on the network, and these ads have high value because they are hyper contextual, to the URL. And basically, advertisers to benefit from ads, they pay with the token. So it's a utility token, and that makes the velocity of the market, where they will buy ads from the users, and so users will have incentives to contribute good content, so they can sell back these tokens.
Right. Thank you.
Good. Thank you. Merci. Ça va, je vais pas trop dépasser.
Non, ça va, c'était très bien. Right, so we're gonna put the mic. It's already on, so if you talk, people will hear you. And then you should connect. Yeah.
Yeah, please. Whoa. It's gonna be fun.
I had the same problem. It seems that you have to open.
Oh.
No, not simply for if there are people standing in the path to tell them to sit down with the fire. Yeah, if people are standing in a pathways.
You don't have water here.